Hey everyone, today we'll be looking at course schedule 2. So I'm kind of in the process of revising the graph problems. So let's see if we are able to do this question in less than 15 minutes. Let's start the timer. So there are total of num course courses. You have to take labeled 0 to num courses minus 1. You're given an array prerequisites where prerequisites of AI, PI indicates that you must take course PI first if you want to take course AI. For example, the pair 0, 1 indicates that to take course 0, you have to take course 1. For indicates that to take course 0, you have to take course 1. Okay. Returning the order of courses you should take a returning the ordering of courses you should take to finish all courses. Mhm. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. Okay, got it. Okay, so we have the number of courses too, and here is the prerequisites. So in order to do one, we gotta do 0 first. So our output would be we have to do 0 first and then 1. Okay, got it. So num courses for prerequisites 1, 0, 2, 0, 3, 1, and 3, 2. So for in order to do 1, we have to do 0 first. In order to do 2, we have to do 0 first. In order to do 3, we have to do 1 first. So, and in order to do 3, we have to do 2 first. So it's clear to us that 2 would be coming at the end, and then once and 1 and 2 can come at any order. As you can see here also there 1 and 2. This would be one of the correct solutions. So yeah, and if there are no prerequisites given, then we can return 0. In that case, return an empty array. Return an empty array. Okay. So my question is like, if what if like the number of courses are 4 and the prerequisites is empty? In that case, what should we do? Basically, um, in that case, I guess there will be no prerequisites. We can do it in any order. Is that so? Okay. So okay, gotcha. And there will be always one num courses, and num courses cannot be 0. If it is 0, then we have to return empty array. In that case, gotcha. AI is not equal to BI. AI is not equal to, okay, they won't be similar. All the pair AI, PI are distinct. So are they distinct and so on and so forth. Okay, got it. So I guess what we have to do here is I found this pretty good website, which is Exali Round, and I guess if I draw, okay, yeah, the session is still open. Um, let's, okay, yeah, here we go. So we have been given like uh, what what all was given to us. Let's see first. I will map it out. So we have been given 1 and 0, 2 and 0, 3 and 1, and 3 and 2. Okay. So here is that um, thingy. So yeah, once we have this, what we can do is one is dependent on zero. So we can draw a circle for every node: 0, 1, 2, 3. So 0, we have to do 0 first, and then we can do 1. So there will be an incoming edge to 1, and then we have to do 0 in order to do 2. So we have incoming from this guy, 0 again. And what we need to do is 3 and 1. So for 3, we have to do 1 and then we can go to 3, right? And then for 3 and 2, we have to do 2, then we can go to 3. Okay, that's what it's saying. Okay, so basically, yeah, I'm gathering my thoughts. I'm gathering my thoughts. I'm checking like what can be done. So our num courses are from 1 to 2000, right? Okay, okay, that would be number. And AI and BI value will be obviously less than um okay, less than 0, and BI would be okay. So my thinking is like we need to find out, so zero's incoming edge will be 0, 1 would be 1, 2 would be 1, and 3 would be um 2, right? So we need to store this somewhere. Where can we do that? Where can we do that? Um, okay, what we can do is, as our num courses, let's go back here. As our so this is the incoming edges count that we need to store. Okay, so once, so what if I had, okay, so what I can do is I can create an array from 0 to the number of courses that have been given to us. Suppose, let's say in this case, let me drag this here. Let me close this tab. And in this case, we have been given four, right? In this case, we have been given 4 nodes. So we can create 1, 2, 3, right? One. In here, we can check the incoming edges for each node. So this guy is 0, this guy is 1, this guy is also 1, this guy is 2. Okay, so this will help us identify how we can, you know, um, traverse. So we have to use topological sort in this case. In topological sort, we see the incoming edges for each node, and whomsoever is not having an edge, like no prerequisites, we have to add that in a queue. So we'll add 0 in the queue. What we'll do is, and we already have a adjacency matrix, right? 0 will have 1 and 2 are dependent on it. Then 1 doesn't have any, 1 have 3 dependent on it. 2 has, 2 has 3 again, and 3 has nothing. So I guess we have to do it other way around. We need to um, check for the incoming edges, right? Incoming edges. So 0 would have nothing incoming, and 1 would have 0 as incoming. Um, 2 has again 0 incoming, and this guy 1 and 2 would be incoming for 3. Using this, we can identify, or or the other way around was right. I guess the other way around was right. Okay, yeah. The other way around is 1 and 2, and this is nothing, this is nothing, and this is, sorry, this is 3, 3, and this 3 would be nothing. Okay, yeah. And once we have to pop we have to traverse the queue until queue becomes 0. Once we pop out queue, we need to check what all edges it goes through. So once it goes through 1, we need to eliminate 0. Like we need to decrement the count from the key from the array. And once we do that, if it becomes 0, then we need to insert it in our result, and then we need to traverse the second element, which is 2. Then we decrement that as well. If it becomes 0, we add it, and then we have to also add it in our queue, 1 and 2. So 1 goes here, and 1 traverses its children. Then this becomes 1. Then 3 is not added as it is not 0. Then again 2 comes. Um, 2 becomes like 2, we traverse 2's element, which is 3, and then again 3 becomes it's 3 values decremented, and then 3 is added to the result, and 3 is also added to queue. There is nothing to be traversed, so yeah, then we come out and then we send out this guy. So yeah, that's how we are going to implement it. I know I spent around 13 minutes explaining it, but I guess that's what needs to be done. For the time complexity of this, we will be visiting node, each node one time. So n n into n number of nodes into the edges that we have, we will be traversing this the topological sort. I'm not sure if the time complexity is right, um, but we'll be storing the array that will be storing our incoming edges count would be O of n, where n is number of nodes available, and yeah, other than that, I guess uh, we'll be storing result, and the queue would be storing all the edges and the adjacency list. So adjacency list would be again O of n. Yeah. So O of n would be the space complexity as well. So let's see. If num courses, why am I typing X? Num courses is less than equal to 0, then return an empty array. An empty array, we need to return an empty array. So other stuff is like we need to create a adjacency list out of the prerequisites that has been given to us. So we need a map, hash map, for us to capture that. Then we need to simply let pre uh, prerequisites, let's call it prerequisites, and of prerequisites. Okay, so prerequisites, and as we are going to do it in Google round, Google Docs, let's do it in Google Docs because our interview uh, is with Google, and need to do it that way so that we are not expecting something else at the day of the interview. So let's zoom in this thing so that you guys are able to see it. Function. Let's disable everything. No grammar check, and in tool preferences, capitalize word. Okay, function. Our function was course scheduler, in which num courses and prerequisites are given to us. Let's just copy this guy because I don't want to um, you know do a spelling mistake. Okay, let's do just, oh my bad. So function num courses prerequisite. Okay, so we have this guy. Then what we do is, if num courses is less than equal to 0, we need to return empty array as defined. And then what we need to do is we need to have a hash map for us to store um, the adjacency, like the dependencies. New map we will use for that, and then we need to traverse let's call it of prerequisites. Need to traverse this guy. Once we do that, what we need to do is, hopefully this is visible. I guess this is visible. Okay, once we do that, what we need to do is we need to destructure the chill. So one we have to do. So how was it like? Let's check. We have to do 0 in order to do 1. So parent, I was trying to find the parent relationship. So parent, so sorry, child, and then parent is equal to 3. So we destructure the parent and child, and now we have to insert it into the adjacency list, right? So yeah, that part is like, if adj list dot has parent, then what we do is adjacency list. In adjacency list, we set parent and we get adjacency list dot get parent, and we push the child onto the returned array. If it is already present, then we would have surely created an array for it. If not, then we have to create an array for it. So adjacency list dot set parent with an array of child. So that's it, right? And okay, once we have done that, I guess this is the right time to update. We have to also create in or incoming edges, new array, num courses. So we create a incoming edges, and for incoming edges, we need to update the child because it is the one from which parent would be sending an outgoing. So child would be receiving the incoming edge from the parent because we have to do the parent first and then the child. Let me reset my camera so that it won't shut down. Okay, so yeah, once we got this, then we have to increment the value plus equals to 1. So incoming edge would increment. And for child, what we need to do for child, like we have to also create a adjacency list for the child, right? Or is it okay that we leave the adjacency list as is? Okay, let's see. Let me think about it. How can we do that? Okay, so if adjacency list dot has child, like we have to check if it doesn't have a child, then in that case, what we'll do is we will create adjacency list set the child with an empty parameter, empty list. Okay, so that if it somehow becomes a parent, then we have the list already. We don't have to create that thing, and we can simply push the child into it. Okay, so I guess we are set here, and then what we need to do is we need to traverse the entire incoming edges and find out whose value is zero, right? Yeah, that's right. We need to find out. Um, so the confusion that I'm having, suppose let's say we have number of edges 6 and we fill it out to be 0. All we are doing here is that okay, got it. Um, what I can do is for let or I equals to 0, I is less than courses I plus plus. Okay, and we need to create a queue, right? We need to add those element in the queue. So if adjacency list dot has I and adjacency list or incoming edges of I equal to 0, in that case we need to add that queue. We need to add that element into the queue. Queue dot push the I into the queue, and yeah, once we have got that, once once we've got the queue, okay, so then what we can do is um, okay, once we've got the queue up and ready, we can run a while loop, and we need to create a result. Let result is equal to this empty array, or we should have defined the result here itself. Let result is equal to an empty array, and then we'll be returning result itself. And while queue dot length is there, we need to do the following operation. What we gotta do is we need to let current node is equal to queue dot shift. Let's call it shift. We'll shift the first element and then let current. So once we shift the current element, current node, what we need to do is that we need to add it to the result, right? Result dot push the current node, once we push the current node, then um, for let node of adjacency list, so we need to see get all the elements that prerequisites or who are dependent on our current node. We will get them from here, and what we'll do is we will decrement incoming edges of the node minus equals to 1 if incoming edges is less than equal to 0, then what we need to do is, oh, we went to the next page. What we need to do is if incoming edges is less than equal to 0, we need to define you what we need to define is Okay, so what we need to, incoming edges is less than equal to 0. We need to put push them to the queue of that node. So we need to push that node to the queue. And okay, so we do this here. Is there anything else that I'm missing? I don't think so. Once that has been taken care of, what we do is, in the end, we obviously have to return result. Other than that, I don't think so we have to do anything else. So yeah, let's do one thing. Let's just copy paste this and see if we are able to run it. It's 31 minutes. We are in this problem. Okay, so okay, so I'm just indenting this guy out so that it would be easier for us to read through this problem. I guess there might be some issues, but we'll see. We'll figure that out. If I just run this, okay, the answer was wrong. Aren't we pushing the current node? So let me just check if console.log, what is the queue that I'm getting here? Okay, I'm getting an empty queue. So let me check what is an incoming edges. Okay, incoming edges. If I run this, what will I get? Oh, did I fill it with 0? No, I did not. Dot fill 0. Okay, now I guess it will run. Current node. If I run this, if adj list dot has current node, then only we'll do this, or else we won't do it, right? Adj get is not a function, or its return value is not iterable, but we are defining an array over and over, right, for everything. So let's check out what's our adj list is. adj list. So our ADJ list is 0 and 1 and 1 and nothing, right? So 0, yeah, we should be going to 1. Okay, yeah, definitely. So ADJ dot get current node is not iterable. That's right. So don't iterate it, just leave it as is. What should we do in this case? Um, let's do this. Let node is equal to current node of I. Okay, and I guess we need to shift this guy. Let R is equal to adj list dot get current node, and let node let I is equal to 0, I is less than R dot length I plus plus. We need to do this. Okay, so yeah, if we try to run this now, okay, wrong answer. 0 is there. We also need to put 1 in there. So yeah, I guess if R equal to 0, but anyways, q dot push. But anyways, when we are traversing 0, then 1 will become -1, and then it should have been added to the queue, right? Console.log. What's that? Incoming edge node. Let's see. Node value is it's taking far more than what I've anticipated, but we are still within our time frame because it's a 45 minutes interview. I know I've not left much time for discussion, but I guess if I can just make it run. Okay, let me also check what's incoming edge after this. Incoming edges. So incoming edges is 0 and 1. That's right. And I'm having this guy add dot length. So oh, add of I. It should be. So this case passed, but these two failed. So output is 0. Why is that? Incoming. Why is this happening? ADJ list. Okay. So 0 is 2, 1 is 1, 2 is 1. So in this case, 2 0, right? Child and parent. Um, I don't get this. Like let temp is equal to adj list dot get parent, then gotta do this temp dot push. Why do we need to pass a reference for it to? Okay, see now also it doesn't come this way. Temp um dot push child, and then all we gotta do is pass this guy here. So see now it's showing 1 2. And what about the third one? Num courses is 1, prerequisites is 0. So yeah, like how are you handling this case? Num courses is 1 and prerequisites. Submissions August 30th, a month back, I guess. Right? Yeah. Okay. Got it. Got it. So the logic that we implemented was almost accurately, it was almost right. But yeah, we needed to do this. We needed to have this guy, and then yeah, once we, I guess, will be able to do this, I guess we can, just return the object, or even if we just do this. Integ integrity. But yeah, I got the idea. So here, I guess I just have to copy this guy and cancel of this. If I run this, submit this. There is some error. I'll just copy this guy for now and just paste this. But I got the thing I was happy about was I was able to recall or able to understand that topological sort is needed here because there are prerequisites. And so yeah, let's try to do some other question. We have already like invested like 46 minutes into this. Let's see the time complexity of this. Okay, who is this Himanshu Jain? Okay, got it. Okay then, let's do this. Let's do some other questions, and for now, this is good. Okay, guys.